the end of the day, still journals are expecting to have this one table which contains the source of the variables, so name of the variable, source of the variables, and also basic statistics of the variables. Otherwise, they are highly ignored. Sometimes journals are even asking that we should put it just in the appendix. But still, this table is required, so we cannot say that we don't care about this one. And also, in many cases, this can provide us red flags about the data set itself. So let's go through central moments and all the other data. And since we have many different experience, is this the appropriate one? Oh, yeah, I downloaded it already, so I should not. Downloaded it where? No. Yeah, just this one is enormous. So. I will upload this one to your folder as well. Because the first thing what we should understand in terms of, or in case of time series, that frequency matters a lot. So there is always a dilemma that how many anomalies do we want to include in our data set, and how many of these anomalies we don't want include in our data set. Because if you are working with annual data, these are the nicest people. So they are quite, they don't have so much outliers, they are not fluctuating as much. So if we are just checking annual data set for the euro US dollar exchange rate, which started 1975, which is really strange, but according to Reuters, we have this data, but obviously this is, so before euro, it was European currency unit, and before of that, I don't know what is this, but they were able to calculate it at the end of the day. So, okay, let's say that we would like to see this one. So we can see that the data set fluctuates. So this exchange rate pair is always having this nice sinus curve design. So it's not appreciating, not depreciating anywhere in the long run. It's just coming back and forth. And in this case, we cannot see so much drama. Okay, maybe in the early 2080s, we can see this rapid depreciation of the US dollars, then after that one is jumping back, but otherwise it looks nice. The problem with annual data, obviously with the low frequency, that it can be short. So usually regression models are operating only nicely if you have 30 data points to start with. So in this case, it means 30 years. if it starts to become shorter and shorter, then model diagnostics will be poorer and poorer. Or for example, maybe diagnostics are still okay, just you start to see unders and tails in your results, so there will be artifacts in the results. So things should be positive, will be negative, or things which should be significant, they are not significant anymore, or the impulse response function just starts to create fairy tales on the long run. So 30 data points are necessary, and the problem is that for many emerging economies we have only data after 2000. But even for advanced economies, if you are checking Eurostat, we have reliable data only from the 90s. So in many cases we can be in trouble with annual data. So that's why I don't like annual data so much. If we are focusing on monthly data, so let's do the same thing for monthly data. The monthly data has the problem of seasonality. Okay, maybe not in the case of currencies, but in other cases, especially when you are using macro variables like GDP, but we don't have mostly GDP, luckily. We have mostly industrial production and other things, so GDP is at least quarterly. But in other cases, we can see this seasonal fluctuation. So first of all, we should deal with seasonality. Once we dealt with seasonality, then we can go to other things. But the benefit of monthly data that we can have huge frequencies. So we can study shorter time periods. For example, right now my paper, which was now under review because reviews went back to the editor, just I don't know the end decision. I started a database in 2016, and the whole data set is about monthly data, and in this case I have plentiful data to deal with. I had to start it in 2016 because that was the time when ECB, European Central Bank, decided all their unconventional monetary policies, and then I wanted to investigate what happened with the rest of the market. So mostly data is nice once we were able to deal with seasonality, but seasonality we just had to hit one button in e-views, and then seasonality will be dealt with, so it's not that difficult as it sounds. Just the problem is that in many cases you don't have such a frequency, so for many years I was also working with quarterly data set, because in this case you don't have the problem of seasonality, at least not so much. So you don't have, theoretically, but still you have way more data than in the annual database. Obviously, if you have only annual data, then you have annual data. So that's, in this case, the sad thing. It's much better that I had this nightmare scenario when some people tried to use annual data and combined it with quarterly data, and then they created this stepwise data set which was not changing only every fourth quarter. So that was terrible, because then it killed the whole model at the end of the day. So unfortunately, if you are working with quarterly data and some of your key variables are only annual, then you have to convert everything to annual. If you are working with monthly data, but some of your data is quarterly, then you have to go to quarterly level. So there is always this downgrading phenomenon for frequencies. And the problem is that if we are moving to higher and higher frequencies, from annual to monthly to daily to hourly, then we have way more outliers in our data sets. So this will be another key problem, that we will allow it to happen such changes which were not there before. So for practical implications, let's see what happens with the differential. So if we are just checking the changes in the data set, okay, let's increase its size, then we can see the following pattern. That in many cases, this thing is changing not that much. So it's increasing a bit, decreasing a bit, but it behaves nicely, so it stays within this 0.05 minus 0.05 interval. But obviously, if we have some kind of a crisis, then it jumps out and we can see that much bigger magnitude. And this can be a key problem because if we have one such a jump, so we have one outlier, then it's always followed by other outliers as well. So this can plague the regression model because we will have outliers, and not just one, but many of them. And also this can plague all the variance-related models, so value S-trees models, option pricing, and all the other things. So that's why, and also p-values in a regression. So that's why we have to deal with them. And that's why it's also nice to check the data set before we are doing anything. That, okay, do we have such a phenomenon? And of course you can say, but yes, just usually we are not using first differential alone in any analysis, because if we have to analyze multiple data sets, so for example, we have to deal with different currencies, then obviously these different currencies will operate at different decimal levels. So this one is fluctuating between 0.6 and 1.6. But for example, Hungarian forint can anywhere between 260 and 440. So to scale everybody down to the same level, this is why people are using logarithmic changes. Except in the case when you are analyzing interest rates, which can be negative, and in the case of interest rates, you cannot use logarithmic changes because negative numbers can have logarithms. So yeah, that's out of question, but in this case we can see that, okay, let's use this variable minus this value. So if it has this nice scaling property, because not this one. Because at the end of the day it looks like the same. So, but it was fluctuating before, it still fluctuates, so doesn't matter. But now it will fluctuate if you are adding additional currencies or other macro variables. Then they will be similarly scaled. But there is always confusion that people sometimes have a tendency to say that once I use the logarithm, then I don't have to care about outliers. No. So logarithmization will not solve any of the outliers. Outliers will be there, it will be eating your model, so you have to deal with this. So there is a huge or really long book written by Green about econometrics, and at the outliers or extreme values part, even he defines this, that you cannot avoid extreme by just using logarithm. So, yes.
So based on your experience, when you use the logarithm, they do not review it. They will ask why you use it, or just they will accept by that.
They will accept it.
No.
I never had a situation where I had to defend or say anything about logarithm, so it's no problem. sometimes people are saying that mixing logarithm and non-logarithmic data is not so nice. But come on, if I'm adding GDP to other variables into a model, then I should logarithmize the GDP, because otherwise I will have huge numbers, enormous coefficients. So Isaac had this in his early version of his thesis, that he was just adding variables without using logarithm because he was afraid of what would happen. And in this case, reviewers of the thesis asked him that please add logarithm because you had 4 million in your coefficients of this. And in this case, the rest of the coefficients were really small numbers, so that's why logarithm can be useful, just you have to be careful to see that negative numbers cannot happen. So especially interest rates. Yeah, so unfortunately, if we are moving backwards towards daily, then we have way more troubles here. Okay, so let's so that one. So we are providing way more chances for extreme stuff to happen, so we can see that now we have clear signs for additional outliers and we have more data sets. So yeah, this is where troubles are happening. So in this case, the easiest way is obviously to compress all these things down to see the distribution of the data. So we should have a histogram, because in this case, can't I rotate this one? If I cannot, then
make it as a picture so you can do it.
Yeah. This will be the ugliest solution. Opposite direction, so this way, that way down. So at the end of the day, if I'm scaling this right, then we can see that obviously in most of the cases, market is not doing anything. So the expected value of the time series will be close to 0. It's really useful because for any regression model, we should use a data which is has 0 expected value. Okay, you can say that in case of ARDR or VACM models, this is not the case, but they are specific models. So for all other traditional regressions, let's say, we need a data set which has 0 expected value, because in this case it will perform well and nicely. Also, we can see that the witness of the body of the distribution will show us that what is the expected frame of potential data. So if this is narrow, so it doesn't like to fluctuate at all, then also the body of the histogram will be really narrow. In this case, the problem will be, this is happening for interest rates many times, that interest rates are doing nothing at all, but once they are changing a lot. So they have this specific non-crisis and crisis behavior, which again makes their modeling harder because they have all the potential anomalies. So that was the reason that we were studying sovereign premiums, so interest rate differential between countries, we were not able to use traditional regression methods. We had to switch to VACMs because this was killing all the models. So usually it should have some thickness in the probability distribution. And also at the tails of the distribution, we can see that what is possible, what is not that possible. So outliers. Okay, so if you have to load this model into, let's use the fancy one. Okay. Sometimes it's not able to recognize what is loaded in, but luckily today it is a good day. No, not today. Okay, so we have already the differential here. So we can just check descriptive statistics. So again, histogram looks like this. But obviously, this guy here shows us a serious trouble. So this should not happen under normal distribution. It shows that the variable should change randomly. Obviously, that universe would be completely boring if this thing would happen. But at daily data set, we never have this luxury to have normal distribution in the data. We have always have the phenomenon called fat tailness, which means that the kurtosis is above 3. So if the kurtosis is at the level of 3, so this is the forced moment, then the probability distribution dies off relatively fast, and it doesn't allow us extreme fluctuations, or so many extreme fluctuations. If this is more than 3, which is always happening. For annual data, it's really close to 3, but for daily data, we will check mostly data sooner or later, we can see that this has its own flows. Otherwise, we can see that, yeah, median is perfect, it's close to 0. Nice. Also, sometimes people are saying that maybe median is much better because they can be different, but you can still see that, okay, they are quite the same. We can the standard deviation. Outside investments and corporate finance, standard deviation is not giving us so many information, so we can say that, okay, maybe this is changing more than other assets, but yeah, who cares? Skewness matters because if this is negative, then it means that it has a tendency to go downwards more than upwards. But right now, this is really close to 0 as well. So if you would check a currency like Hungarian forint against the euro, which has a tendency to depreciate a lot, and during this whole history, then we can see that this skewness would be way more negative than this one here. Also, kurtosis. So we can see right now the pinnacle of currency pairs, so euro and US dollars. All the rest of the currencies will have bigger kurtosis than this one. So this is the sad news that, and still currencies, free floating currencies, so which are not so many times managed by central banks like other non-floating currencies, are still behaving much better than government bonds, government bond yields, and also corporate shares. So these are the best behaving data what you can see here. Otherwise, they are kurtosis can be for emerging currencies around 10 or even bigger, and also for corporate shares it can be way bigger, and it's around 20 for different bonds. So this is the nightmare scenario because this shows us that we have to deal with outliers later on. Okay, so let's have descriptive statistics. Let's save it to create a nice, a nice output. Daily. Okay, also we have, we have this stupid decimal comma decimal point issue because in Central Europe everybody uses decimal comma, in Anglo-Saxon world everybody using decimal points. So at the end of the day when we have to convert back and forth, this can create problems. So if we are looking for the designated levels, we don't care about minimum maximum levels. People are just keeping it in the table, but if you are getting rid of this is no problem. Okay, so in optimal scenario, this median according to the lecture note, this should be 0. Standard deviation doesn't matter. Skewness should be 0 because in this case we don't have any asymmetry in our data. So this would be completely perfectly symmetric. So if it goes down, it goes up, it goes down. So it's following the sinus curve. And kurtosis is 3. So not much extreme changes within the data, which is good because after that we don't have to care about outliers. Not at all, but they will not infesting the model. Also, the Jark-Bera is the normal distribution test. So its probability should be bigger. It should be bigger than 0.05. And this is a backward statistic, so right now it fails miserably. It always fails. So if we are lucky in case of the euro-US dollar exchange rate in quarterly data set, then you can have a chance to have it to be normal distributed levels, or the other variable what I was able to find to be normal distributed was cocoa prices, and that's all. So they are never normal distributed. Okay, we don't care about them. Is this data? Okay, observations can be nice, so we are not deleting it. But we need additional features. So first of all, autocorrelation. So this thing has a build-up in nature. So let's show you that what I'm talking about. So it's going somewhere. It's going down, it's going up, but it remembers what happened last day, or during the previous days, or during the last month. We had this paper when we were analyzing Dow Jones Industrial from the last century data, and it has always the same issue that sometimes the memory of the data set went backwards with the month. And it doesn't matter that we are in a crisis mode or non-crisis mode. It was not significant in terms of recession period, but it has a tendency that it remembers that yesterday the forint was depreciating. Okay, it will depreciate today as well. So we have this periods when it remembers a lot backwards. So that's why we should think about autocorrelation. So this is the Young box test, and autocorrect is so nice, just utterly useless here. And so in this case, Young box test will give us that if there is autocorrelation of the data set, then we will have to increase lag numbers in the model because we have to deal with this. Otherwise, autocorrelation will create some results for us, but they will be absolutely biased in the regression model. So p-value should be above 0.05. In the log numbers, and yeah, in this case I should also write it here. Outliers, outliers. Okay, so let's see the mistakes. Wow. Coralogram. You don't have Jungbox test? Come on. We have HP filter, frequency filtering. Wow, it doesn't have Jungbox test. I will talk about this one later. That's sad. Okay, so this is the best what I can offer. Still okay-ish, because we can see that yeah, these probabilities are less than 0.05. Just Qstat is the same like Jungbox, just a bit different. Okay, for some reasons they did not. Oh, I already used the differential. That's a problem. So coralogram level. Okay, now it's good. Let's see that do we have any cert date. No, it's cool. Okay. So right now we can see that this specific time series have no such a problem. Usually when we are just focusing on diagnostics, we are just focusing on one leg backwards. So because usually this is the case when this phenomenon happens, that the previous data will affect today's data, but right now we can't say that it has an impact because it's 0.6. So let's see. Cool. We don't have this, which is strange, but okay. The other phenomenon is heteroscedasticity. So it means, okay. Heteroscedasticity is much better to show you. Is this phenomenon that for some time period, for a short or sometimes longer time period, the volatility is quite limited. And then when a crisis happens, then this volatility increases significantly, so practically it doubles. And we have a high standard deviation for this time period, and after that it drops. Again, it goes back to earlier levels. This is an issue of the high frequency data, so this is not a problem for a quarterly, monthly, or annual data set. We can perfectly ignore it. All the regression models are robust against heteroscedasticity, so this is no problem for us. If you have to work with daily data, if you have to work with correlation between variables, then this can be a problem. So that's why gauge models, we will have to talk about them later, because they can generate so many anomalies. And also, if you would like to have volatility for your data set, so for example, a price volatility, that were they able to price in the asset with a confidence or not? Because in this case, we can say that they had a nice confidence about what should be the value of US dollar against euro, because this is not fluctuating so much. Here we can say that they lost this confidence. So when prices are increasing drastically, it means that they have no idea what should be the price level, so volatility increases. But this means as well that you cannot use the differentiated data for correlation estimation immediately, because in this case you will add also this bias here. So that's why all these conditional models, gauge models, DCC gauge models were designed. That was the key story during the 90s and the early 2000s, that everybody was developing their own gauge models. And in this case, let's see that, do we have any variance ratio tests? Oh, they excluded several tests from the, because this from this one this is missing. Long run variance. Okay, that's strange, but anyway, so they are not including, but ArchLM test should be somewhere in the software. So and in this case, if we have this trouble, then we should have gauge modeling. But usually it's above, so it's for daily dataset it can be a problem, but otherwise not. And last one is stationarity. So, oh my god, when I started so when I was a PhD student, like you, just with way poorer econometric knowledge, it was always coming up that I had to learn all the econometrics on my own. So we had no specific class for it. We had no any kind of education. So I had to go for such a class to the Boya Institute. And when I tried to learn about stationarity, because I was able to see stationarity here, there, and so on, it was always troublesome, really long definitions, and so on, which was utterly useless, because at the end of the day, what matters us, that if you are thinking about the time series, if you are creating this sample from here, the mean and the standard deviation should be the same like here. And obviously, the mean will be nearly zero. Standard deviation, if we are excluding these anomalies here, also it will be similar. So mean and standard deviation will not depend on sampling or time. So this is weak stationarity. So for us, for macro data, and especially macro financial data, if we are using a differential on anything, then the data set will be stationary at the end of the day, because we can use only stationary input for regressions. If you are not doing it, then we have false results, completely false results. We can also use non-stationary data, because in many cases, VACM and ERDR models are preferring variables which are not stationary, or they are preferring level data, so without differentiation, and after differentiation it can be, or for ERDR it can be completely mixed. VACM is much more peaky in this case, but still everything is about differentiation and stationarity, but this works. So that's why we are just taking the difference between the two time series, and after that p-value should be smaller than 0.05. So unit root test standard. People are always saying that, oh, we should not use the ADF test. Even in the big financial econometrics book, it was written already in the 2000. And still, if you are checking high quality journal papers, still they are using ADF test. So who cares?
Can you show both of them? Philips Buron and
yes,
ADF?
yes. So just let's go through the. So we have EDF test and p-value. So this fits always. Yeah. So what is really popular nowadays? The Phillips-Perron test. But I'm always using just one leg. I don't care about the best fitting model here because come on, it should be good. So sometimes I feel that this thing is overemphasized because it's always working. So this is only in case of interest rates we can have the anomaly that we should use 2 times the differentiation. But or when people are analyzing term spreads or different interest rates spreads, this can have such an anomaly, but this is nice. So or breakpoint things. So I never had a feedback until today that when they were asking for any sophisticated stationarity tests. So there was never the problem. So if we meet this, then the data set can go immediately to the regression. Workflow here. Okay, so yeah, that's all for today. And I will upload. So if we would have MATLAB, then we have a whole basic statistics M file which contains all these things. Just in this case, we can just hit F9 and then it will go through. Maybe next week I can show it to you when we have MATLAB, maybe, and all the other things. Yeah. Also, please check the lecture notes because some definitions are here, or if or also we started this one as a cookbook because we had to define the same thing or describe the same thing in different papers again and again, and it was much better just to collect these literatures and the citations and where can we find these things. So if you are interested in one part, then you can always find the related literature here and there. For example, in the Green Book, which pages dealing with this phenomenon. So yeah. Okay, so that's all. Do you have any question for today? If not, then see you next week, where we continue our journey in the field of
in terms of the stationary test. So I mean, like inside our journals, like we can show both of the tests. Like we can put the result of ADF and Phillips.
Yes.
So also.
That's all. It's enough. If one reviewer is picky, then they can ask that, okay, please add the further test, but it will be all good. So some people really like stationary tests, but mostly they're just there and they are doing their job, and differentiation will solve the problem. So mostly they are ignored. But this table must be added to the paper, but otherwise it really doesn't have much consequence. Just it will highlight us that, oh my god, we should deal with outliers, oh my god, we should deal with log numbers in the model. Maybe Gauge model, but usually for your data set it will be irrelevant, or differentials must be used. And yes, we are using differential data. So, yeah. Okay. If you don't have any further questions, then thank you very much for being here. And next week we will dealing with other things.